Let's begin by defining inflammation. It is your body's response to tissue damage. It is part of the innate immune response, your second level of defense or second line of defense. This response can be due to a variety of different sources of damage. It could be heat, chemical, cold, trauma, or a pathogen. There are several benefits to inflammation. I'm going to list them and then we'll talk about them in more detail later. Let's begin by defining. But inflammation prevents the spread of the pathogen, removes dead and damaged cells, as well as cellular components or debris, eliminates the pathogen, triggers the adaptive immune system, and initiates tissue repair. There are several chemicals that are going to be involved in initiating or directing the inflammation process. Histamine is released by mast cells and basophils, and it will initiate inflammation. Serotonin is released by activated platelets. Cytokines are released primarily by leukocytes. Bradykinin is a plasma protein. And prostaglandins and leukotrienes are local hormones released by cells. There are 3 steps in inflammation. The first step is vasodilation. The inflammation mediators bring about relaxation of the smooth muscles in the arterioles feeding the damaged tissue. As a result of vasodilation, increased blood flow to the area occurs. This increased blood flow is called local hyperemia. This results in one of the signs of inflammation, redness. Another sign of inflammation is heat. Water, which makes up the majority of your plasma, has a high heat capacity, which means that it can carry a lot of energy in the form of heat before it changes its temperature. If you have increased blood flow to the area, you will have increased heat to the area. There are several benefits to this increased blood flow to the area and increased heat. Let's talk about the increased blood flow first. Blood is carrying with it plasma proteins. These include antibodies, which will be used against antigens, foreign antigens. Complement, which we've already talked about the complement process. Recall that complements can enhance inflammation, function as opsonins to enhance phagocytosis, and form membrane attack complexes, or MACs. In addition, clotting factors will be carried to the area as well, which will be used to bring about coagulation. The coagulation with the fibrin mesh helps wall off the area to prevent the spread of the pathogen. The heat increases metabolism, or your metabolic rate. In addition, the heat is believed to increase respiratory burst in neutrophils. The respiratory burst occurs when neutrophils increase their oxygen consumption and use that superoxide to produce hydrogen peroxide. Hydrogen peroxide can be used to kill pathogens, bacteria, And the hydrogen peroxide can be converted into a chemical which is found in bleach, which can also be used to kill bacteria. The second step in inflammation is leukocytosis. Recall that this term means that you have elevated levels of leukocytes in your blood. Damaged tissue cells will release leukocytosis-inducing factor. Leukocytes will release cytokines such as interleukins. These will go to the red bone marrow and increase leukopoiesis, or white blood cell production, which will result in leukocytosis. The primary leukocyte that will be increased is your neutrophil, but macrophages will also be increased. Both neutrophils and macrophages are phagocytic cells, so they will move to the site of injury. The third step is increased permeability. The capillaries will become more leaky. Endothelial cells that make up the walls of the capillaries will contract, increasing the space between them, the intercellular clefts. This will allow leukocytes as well as the protein-rich plasma to leave the blood vessel and go to the tissues. This will result in swelling or edema. This is another sign of inflammation. The plasma with the proteins in it is called exudate. This will be rich in complement, antibodies, as well as clotting factors, and nutrients that will be used for the repair, as well as oxygen. Increased oxygen will allow you to increase ATP synthesis, which will be used for repair and growth. Some of the inflammation mediators or inflammatory mediators will stimulate pain receptors, as well as the edema. Pain can be helpful because it will prevent you from moving the limb, allowing the repair to occur, and also to prevent you from damaging the limb or the area more. It will make you aware of the damage. Let's look at phagocytic mobilization, getting the phagocytes to the area. It begins with leukocytosis, elevated white blood cell levels in the blood. This is due to increased leukopoiesis at the red bone marrow. The second step in mobilization is margination. Margination involves stopping the leukocytes at the site where they need to leave the blood vessel. This will involve proteins called cell adhesion molecules, or CAMs. Endothelial cells will express CAMs on their membranes when they are inflamed or damaged. Leukocytes will also express CAMs. When the leukocytes come across the CAMs on the endothelial cells, they will bind, and this will stop the leukocytes. After the leukocytes stop at the area where they need to leave, they will squeeze between the endothelial cells, and this is called diapedesis. This is the process by which they leave the capillary and move into the interstitial fluid. They are able to find the area of damage by following chemicals. This is positive chemotaxis. They move toward these chemicals. They have receptors for the chemicals. The chemicals can include chemicals released by damaged tissues, as well as chemicals that are released by the pathogens. For number one here, we've already talked about leukocytosis, increased Leukopoiesis results in increased levels of white blood cell in your blood. Margination, recall, is where the leukocytes bind to the endothelial cells by way of the CAMs, and that's how they know where to stop. So this is what's going on here. Diapedesis is the leukocyte, and we're talking about neutrophils here, leaving the blood vessel by squeezing in between two adjacent endothelial cells. And then positive chemotaxis is the leukocyte moving toward chemicals that are released by the damaged tissue or by the pathogens themselves. In this illustration, you've got a leukocyte here. Let's say this is a neutrophil. These green structures are CAMs. This is the endothelium. So these endothelial cells are expressing CAMs as well. When the leukocyte or the neutrophil CAM comes in contact with an endothelial CAM, they bind. This stops the leukocyte. This is the margination. And then the leukocyte will squeeze in between adjacent endothelial cells, and that's the diapedesis, and move toward chemicals by chemotaxis to the injured site. This is a good way to put it all together. You may want to stop the video and copy this flowchart down.